Hi everyone, my name is Madhura Bhave and I'm a developer on the Spring Boot team at VMware. If you're a Spring user, which you probably are if you're watching this talk, you might have wondered how Spring works behind the scenes. How does Spring create and manage all of the bean instances that form the backbone of your application? At this point, some of you might be thinking this: it's just annotations. How hard can it be? Well, turns out that there's a lot that goes on behind those annotations. In today's talk, we'll be taking a deeper look at what goes on behind some of those annotations. For the purposes of this talk, I'll be using a demo application, which is a simple Hello World application. It is a Spring Boot application to make the demo simpler. If we take a quick look at the build.gradle file, it's using Spring Boot version 3.0, which was released in November 2022. In the dependencies section, you can see it's using Spring Boot Starter Web, which means that it's going to be a web application which starts up Tomcat. I've got a series of commits lined up here, and we'll be checking out the commits as we build the application throughout the talk. If we look at the main method, it's a very simple application. It's got a single method, which is going to be called when we run the application. So let's run the app. We can see that the application started, and it started a Tomcat web server on port 8080. Now, if I try to hit any of these endpoints that might be present on the application, let's try and hit the root endpoint on port 8080. We can see that we get the expected 404 not found. And that's because we haven't configured any request mappings to handle this request. We can do that by adding a controller. So in this next commit, we've added a controller to the application. It's a simple REST controller with a single get mapping at the hello path, and it returns the string hello world. Now, if I restart the application, and try hitting hello this time, because that's what the path that we configured the REST controller at, we still get a 404, even though we've added our REST controller. And the reason is that even though we've added this class to the application, we haven't told Spring about this class. Spring doesn't know that this controller exists and that it should configure it and configure the request mappings that are present in it. So in order to fix that, we can check out the next commit. And what that does is it adds the component scan annotation. Some of you might have seen the component scan annotation before. If you're a Spring Boot user and you haven't seen this annotation before, it's hidden behind the @SpringBoot application annotation. Now let's give that a go. And try our hello endpoint again. And this time we get hello world back with the HTTP status 200. So why did this work? We added the component scan annotation, but how did that tell Spring that it needs to configure the controller? You can think of component scan as two different parts. Component is something in Spring that can be scanned in order to create beans. Component can be used as a meta annotation. So some of the more familiar ones are service, repository, and controller. These are all annotated with @component themselves. It can also be used as a meta annotation. For example, the REST controller, which is annotated with @controller, and in turn, @controller is annotated with @component. So what does scanning do? When component scan is added to the application, Spring looks at all of the classes that are present in the package of the class that the annotation is declared on and its sub-packages. It finds candidate components based on the annotation being present on the class and creates bean instances for them. Imagine that our application has a few more classes. In this case, there's a couple of utils classes, and we have the hello service class and the hello controller class. When Spring encounters these classes, it sees hello utils, it doesn't have a component annotation on it, and it does nothing about it. It sees hello service, which is annotated with that service, which is a component, so it creates a bean for it. It sees the controller, which is annotated with that REST controller, which is meta annotated with that component, and hence creates a bean for it too. And for my other utils, it sees that it's not a component and decides not to do anything about it. So when Spring sees the hello controller and creates the bean for it, how does it create that bean instance? How does it know what to do when it creates the bean instance? It first creates a bean definition for it. The bean definition is then used to make the bean instance. Okay, but what's a bean definition? Think of a bean definition as the blueprint for a bean instance. In the Java code, the bean definition is represented using the bean definition interface. It has a bunch of metadata on it that tells Spring what to do when it creates the bean instance using the bean definition. Some of the attributes in that metadata include things like whether the bean should be created lazily or not, and that's something that you can do if you have the @lazy annotation on your bean. Whether the bean is primary or not, what scope it should be, the type of the bean, the factory method name, and some of the lifecycle methods for the bean, such as the init method name and the destroy method name. Okay, so we have this bean definition, and we said that bean definitions are needed in order to create the bean instances, which means that we have a lot of bean definitions, one for every bean instance that gets created by the framework. But where do we get these bean instances from using the bean definitions? And where do the bean definitions get registered? At the highest level, we have the bean factory interface, which gives us the bean instances using those bean definitions. And we have the bean definition registry interface, which lets us register bean definitions. There are many implementations of the bean factory, but in the framework where the two interfaces come together are the default listable bean factory. The default listable bean factory implements both the bean factory and the bean definition registry. It's important to know about the default listable bean factory because it forms the heart of Spring. It manages bean definitions because it implements the bean definition registry, and it also manages bean instances because it implements bean factory. Now let's jump back to the code to add a little bit more functionality to our application. So we're going to extract the message that the controller returned into a separate class. Instead of returning the hello world string directly from the controller method, I've created this hello message provider class, which is basically a service that has a single method that gives us the hello world message. The hello message provider can then be used in the hello controller. It's passed into the constructor of the hello controller, and then it's used in the method body. In order to configure a bean for the hello message provider, this time instead of annotating it with @component, I've created an explicit bean method for it in a configuration class. This is another way to create beans in the Spring framework. You can do this if you want to create beans for classes that you don't own, or if you have a more complicated setup for creating beans, which component scanning might not help with, or if you prefer this in general over component scanning. Let's give that a go and see if we still get the same message that we got before. So the application actually failed this time. As you can see, the application failed to start. And the error message says that the parameter 0 of constructor in hello controller, it required a bean of type hello message provider that could not be found. And if we scroll up a little bit, we can see that there's an error starting the application context. So far, we've been talking about the bean factory. And that's how we get our bean instances. And the bean definition registry is where we register our bean instances or our bean definitions. So what's the application context and where does that come from? The application context is an implementation of the bean factory, and it provides some enhancements on top of the bean factory. It's useful to know that there's a clear separation between the application context and the bean factory within the framework itself. The bean factory is part of the Spring Beans jar, and it provides the foundational components for the Spring IOC container. The application context builds on top of the Spring Beans jar, or rather the Spring Context jar builds on top of the Spring Beans jar and provides additional functionality on top of Spring Beans. Some of the additional functionality that application context provides includes support for application event publishing, the environment abstraction, which contains properties from a variety of property sources, message source, which provides support for internationalization, and support for configuration classes and scanning. Let's dive into the hierarchy of the application context a little bit. Abstract application context is the base implementation that can detect special beans. These special beans can include post-processors such as the bean post-processors or the bean factory post-processors, which we will look into a little bit later. Generic application context is one of the more commonly found application contexts in a lot of applications, or some variant of the generic application context is what you'll typically find. It's special because it contains a default listable bean factory. This can be a bit confusing because application context itself implements bean factory. But the generic application context also holds a default listable bean factory, which allows for registration of bean definitions, and in turn, getting the bean instances from those bean definitions. And finally, we have the annotation config application context. And this is what adds the configuration support and support for scanning. Okay, so now that we know a little bit more about the application context, we can go ahead and fix the error that we got because our bean was not available to the hello controller. And the way to fix it is, as you can imagine, by adding add configuration. So the hello configuration is now annotated with add configuration. And if we run the application now, it starts up. Again, Tomcat started up on port 8080. And if I try to hit the hello endpoint, we should get the expected output of hello world with a status of HTTP 200. So why did that work? We added the add configuration annotation to our application configuration, and that's bean for the hello message provider. And this worked because configuration itself is also a component. It's meta annotated with the component annotation, which means it also gets picked up by component scanning. When configuration classes are picked up by component scanning, they are scanned for bean methods. And when a bean method is found, a bean definition is created for it. In this case, we get a bean definition which looks like this. We get a type of hello message provider. The factory bean is application configuration because we need an instance of the application configuration class in order to invoke this bean method. and the factory method name is message provider. That method gets invoked when the bean instance is needed. It's important to note here that the type of the bean definition comes from the method signature and not from what gets returned from the method body. This means that it's best to be most specific in the method signature so that Spring has the most accurate information when it creates the bean definition. Okay, so we see how the bean definition for our message provider gets created because it's defined in our configuration class. And then we know that our controller needs this bean injected into it because it depends on the message provider. So how does that work? We have all of these bean definitions. So we have one for our hello controller, and we have one for the application configuration. These are all contained within our default listable bean factory, which is where these bean definitions get registered. And the annotation config application context is what holds this default listable bean factory. Now, when Spring tries to wire up all of the web components, it needs all of the controller beans in order to configure all of the request mappings that are defined in them. In this case, we have our hello controller. So it says, okay, get me the hello controller bean. It looks at the bean definition of the hello controller and sees that it needs a hello message provider because that's what's injected in its constructor. It then goes on and gets the bean definition for hello message provider. From that bean definition, it sees that it needs the application configuration factory bean. So it has to go and get the bean definition for the application configuration. In this case, the application configuration has no dependencies, so it's able to create a bean instance for the application configuration. It can then invoke the message provider method on the application configuration bean instance to get a hello message provider bean instance. And lastly, it can then create the hello controller bean instance by injecting the bean instance that was created for hello message provider. So we looked a little bit at how annotation config application context can register and get beans, but how does it process the configuration classes in order to determine what those bean methods are? For that, it uses a configuration class postprocessor. The concept of postprocessors is quite prevalent throughout the Spring framework. You can have something like a bean factory postprocessor, you can have a bean definition registry postprocessor, or even a bean postprocessor to postprocess bean instances. The configuration class postprocessor is a bean definition registry postprocessor. So a bean definition registry postprocessor allows you to modify the bean definition registry by adding more bean definitions to it. So when the configuration class postprocessor finds the beans that are defined in the configuration class, it creates bean definitions for them and registers them because it implements the bean definition registry. It's also a bean factory postprocessor, so it can modify the bean factory as well. Let's go back to our code and use a bean definition registry postprocessor to see how we can manually register beans in our application context. So in the same hello configuration class, I've created a nested class called hello postprocessor, which implements the bean definition registry postprocessor. The interesting bit is in this postprocess bean definition registry method. So we can create a bean definition manually for a class. In this case, I have a hello name provider class. The hello name provider is a simple class which gives us the name that we want to use in our hello message. It's used in the hello message provider, So instead instead of hard coding the string world, we're now getting the name that we want to greet in using this message provider from the hello name provider. As you can see, it's injected into the constructor of the hello message provider. And then when we create the bean definition for this hello name provider, we can set an instance supplier on it. So in this case, all I want to do is create a new hello name provider. It's pretty straightforward. And then I can register the bean definition with the bean definition registry by providing a bean name. The bean definition registry post-processor itself can be registered as a bean. It needs to be static so it doesn't cause any early initialization issues. If I run the application with this now, and if I call our hello endpoint, you can see that it returns hello SpringOne instead of hello world. So this is another way of registering beans if you prefer using this over defining beans using bean methods or component scanning. The reason why I showed you the manual registration of bean definitions is to give us a good segue into the next section, which is running Spring applications as native images on the GraalVM. Support for running applications on the GraalVM was added in Spring Boot 3 and Spring Framework 6, which was released in November 2022. Unlike the JVM, the GraalVM makes a closed world assumption. It needs to know about all of the classes that will end up in the final native image ahead of time. So it analyzes the call stack and discards any classes, fields, methods that are not used directly. So what would it do in the case of our demo application? It would find our main method. From there, it would find our Spring application.run. From there, it would see the annotations, the component scan annotations, maybe the configuration and the bean annotations. But from there, it just wouldn't know what to do. And it could end up in a pretty bad mess. So in order to support GraalVM or Spring applications on the GraalVM, we could add reflection hints. And adding reflection hints for every single thing that we need in the final native image is not the best solution. Or we could write better code. And this gave us an idea. We said, okay, we have something that looks like this. So we have our configuration class, which is annotated with add configuration, and it has our bean methods annotated with add beans. And then we could turn it into something more like this. So this looks more like the manual bean definition that we just saw that was registered with the bean definition registry post-processor. Okay, so it's just annotations. How hard can it be, right? Taking those annotations and converting those into code? Well, that can be pretty complicated. So we had a better idea. We already have the bean definitions that Spring knows how to create based on the annotations. Why not use those bean definitions in order to create the code that we want? And that's what we did. So the way it works in Spring Framework 6 is we run the application so that we have the bean definitions. Here's our default listable bean factory, our annotation config application context, as we saw before, with all of the bean definitions. But we then stop before we create the bean instances. At this point, now that we have the bean definitions, we can generate code that can recreate the bean definitions. Of course, there's a little bit more to it than that. And then once we have the generated code, we can let GraalVM do what it needs to do based on that generated code. It will look at the bean definitions in the generated code, follow the breadcrumbs, and create the native image. Let's take a look at what that looks like in practice. So the last commit that I have here, what it does is, all it does is it adds the GraalVM Build Tools native plugin. The Spring Boot Gradle plugin reacts to this plugin and it configures the process AOT task, which we can run in order to see what the generated code looks like. So I'm going to run Gradle process AOT. AOT stands for ahead of time, which means process the application context ahead of time in order to generate the code. And now we can take a look at what some of that generated code looks like. So it gets generated in our build folder for Gradle. It's in this AOT sources folder. For our application, we have the example package, hello world, and then we have a few classes that get generated. The most interesting one that we can look at here in order to see what's going on is the hello configuration bean definitions. So if I expand that a little bit, you can see that it created some bean definitions for all of the things in hello configuration. So this is the bean definition for the hello configuration class itself. So you can see that the bean type is hello configuration. This is the root bean definition that might seem familiar based on the bean definition that we created manually a few minutes ago. And then it has the instance supplier. This is a proxy that Spring creates for configuration classes in order to allow you to call bean methods directly. If you don't want this proxy creation for configuration classes, there's an attribute on the annotation, which is proxy methods, and it can be set to false, proxy bean methods. There's also a bean message or a bean definition for our message provider. So the bean type is hello message provider. And it has an instance supplier for that as well, which is a little bit more involved than the instance supplier for the configuration class because it has some other things like the hello name provider injected into it. And then lastly, we have a bean definition for the bean definition registry post processor as well. These bean definitions, they eventually get used in this class, which is called Hello World Application Bean Factory Registrations. So all of the bean definitions that are created by the generated code are then eventually registered into the bean factory using this register bean definition, and it calls the methods to get those bean definitions from the respective classes. So that's how we end up with code that GraalVM can trace, and it knows exactly which classes it needs to keep and which classes it needs to discard. And that's all I had for today. Thanks.